Good day. I'm going to attempt to explain a little bit of background for Newton's second law, especially when we're looking at forces. This is a skill that we are revising, but I think it's very important for you to just remember this as we go forward. So quickly, if we look here, we've got a guy pulling a object at an angle of 60 degrees with a force of 150 Newton and a frictional force of 15 Newton. Now what you do first on this question, you are going to draw a diagram. Now if we look at the diagram, we draw the object as a block, okay, and we have that force of 150 Newton at 60 degrees, okay. Now we have to break this angle into components. This angle actually has a horizontal component, which we can call Fx or Fax, and a vertical component, Fay. Okay, so we're going to break these into components. We're going to use the trigonometric ratio where we say that this is Fx, Fax, that's the applied force, Fay. Okay, and when we measure something like this, I always try and measure from the x-axis. Remember what we use for trigonometry. We remember the side that has the angle is the cos. So here we can see the horizontal has the angle, so the horizontal component is going to be Fa cos theta, and the vertical component is going to be Fa sine theta. Okay, so if we substitute that, that's going to be 150 Newton cos 60, and this is going to be 150 Newton sine 60. Okay, so that's what you do when you calculate something like this. We're going to have to, I'm just going to work on this side, we're going to have to add all the other forces. So what I suggest is you take your forces, already put them in angles, and you have draw all the forces on the object. Okay, so in this case, because it's being pulled at an angle, we cannot ignore the normal reaction force and the weight. Here we've got friction force, we've got the applied force vertical component, applied force horizontal component. Since this force has a vertical component, we cannot simply ignore those two forces. So what we learned before is that we can only add up forces working in the same line or the same plane. So the horizontal forces will act upon each other and the vertical forces will act upon each other. Now if we go back to our picture, we will see that this box will not fly up in the air or down into the ground. So these forces going up and down will cancel. Okay, now what's left is the horizontal forces. And if the object is moving towards the left, okay, or right in this case, then that means our vertical component should be bigger. So when we calculate our Newton's second law, we're going to say the resultant force is mass times acceleration. In this case, the resultant force consists of the x component minus the frictional force times is equal to the mass times the acceleration. And that's how you would solve a question where the object is at an angle.